So dear students, let us discuss this interesting example. Okay. So this differential equation we have and our target is to find its solution. Okay. So let me note down the given differential equation first. What is the differential equation we have? We have dy by dx, right, is equal to x cube y cube minus xy. So see, this is a first order linear differential equation since we have simply dy by dx here. Okay, but see y raised to n is there, that kind of term we have. So I feel that it is Bernoulli's differential equation. Okay, so you will feel the same if I give you the standard format. Actually, I have already covered in previous video. The standard format of Bernoulli's differential equation is this one, where p and q are functions of x only. So when you have higher power of y cube, y raised to 4, y raised to 5, y raised to 6, it means it is Bernoulli's equation, right? So we have this kind of term here, y raised to 3. So I feel that it is Bernoulli's equation. But see, it doesn't appear in a standard format. The standard format contains two terms in the left hand side, only one term we have in the right hand side. But see here, exactly opposite, we have two terms in the right hand side and one term in the left hand side. That means out of these two, one term need to be shifted in left hand side. So guess just which term should be shifted out of these two? Xy should be shifted here since this y raised to n term appears in right hand side. So that's why I'm going to shift this xy in left hand side. So what will I get? Dy by dx plus xy, here we had minus sign, that's why x cube y cube. Okay, now it looks perfect. Dy by dx, p means function of x we got, p is x, q is again function of x cube, right? Y raised to n there we have, and here y raised to 3, n is equal to 3. So it is Bernoulli's equation. In previous video we have already seen what is Bernoulli's equation and how to solve. But see, I will tell you the method again, and with the help of that method we are going to solve this problem. So when you have such Bernoulli's equation, our first task must be divide the entire differential equation by y cube. Y cube, that means whatever the y raised to n like term you have here. Okay, let us divide the entire differential equation by this term y cube. Why we are dividing by y cube? The reason is that in first order linear differential equation, right hand side should contain just function of x only. We don't want y or any function of y there. So let us divide both sides by y cube. Okay, so let me clearly mention, dividing both sides by y cube. So let us see what will happen. Let us divide the each term by y cube. So in first term, 1 upon y cube will appear like this, dy by dx. If I divide the middle term by y cube, y is already there, so one y will get cancelled, and we will have x upon y square. In right hand side, y cube will get cancelled, x cube. Okay, so yes, finally we got just function of x in right hand side. But see, our this initiative disturbed the left hand side. Actually, we want just dy by dx, but we got 1 upon y cube also. So again, there is one solution. We use the substitution. So what is that substitution? Whatever the 1 upon y square, here I got 1 upon y square. Sometimes you will have y cube y raised to 4. You should put it as u. Okay, 1 upon y square is equal to u. I am going to put, right? Okay. See, if you put anything in differential equation, our next step should be take its derivative. Okay, so I will do the same, but I feel it is difficult to take the derivative directly. I am going to shift y square to the numerator, then power will be negative, y raised to minus 2 is equal to u. Now I can take its derivative easily since I know this formula. Derivative of x raised to n, which is n x raised to n minus 1. So will you tell me what will be its derivative? If I use that formula here, what will be its derivative? Whatever the power, okay, whatever the power, we should write it first, minus 2, and we should reduce the power by 1. So y raised to minus 2, if you reduce 1, so you will get y raised to minus 3. And again derivative of y, dy by dx. In the right hand side we have derivative of u, which is du by dx. Okay, So let us, minus 2 is a constant. Let us shift on that side. Y raised to minus 3 dy by dx is equal to it is multiplication. So it will be division now, du by dx. Okay, so let me write in a more proper way. Power is negative. So that's why I'm shifting to the denominator. Now it looks better, no? Minus 1 by 2 du by dx. Okay. See, 1 upon y cube. Same term we have 1 upon y cube dy by dx. That means the first term will be replaced by this minus 1 by 2 du by dx. And 1 upon y square will be replaced by u. So then 1 becomes, let us write, 1 becomes. So let me remove this part. It is not required now. Okay. 1 becomes, let us see. The first term will be replaced by that minus 1 by 2 du by dx plus x. 1 upon y square will be u x cube. Okay, now it looks better. So what is our final target? Our target is to bring the standard format of first order linear differential equation. What is standard format of first order linear differential equation? Dy by dx plus py is equal to q. So this is the standard format of first order linear differential equation. Why we are bringing? Since if you bring in that format, we have a fixed method of getting solution. Okay, so that is the main reason. So I'm going to bring the format. Okay, initially we had some y raised to something we had. So we shifted here. Okay, then we substituted. But see, we have just dy by dx only. And we have that minus 1 by 2. That means that minus 1 by 2 is still troubling us. So that's why I will multiply both sides by minus 2. Multiplying by minus 2. What will happen? This minus 2 will get cancelled. We will have dy by dx. If you multiply by minus 2, minus 2xu. If you multiply by minus 2, minus 2x cube. Now it looks same, right? It looks same. Du by dx. Here we have dy by dx. At a place of y, we have u. P is a multiple of y. So here p, which is multiple of u, which is obviously minus 2x. And q means right hand side, which is a function of x. We have minus 2x cube. So finally we got our p and q. Now the method is fixed to get the solution. First we find integrating factor. If you have already seen my previous video, you are familiar with all this method, getting? So we find integrating factor and then directly we go for the solution. The integrating factor is e raised to integration p dx, e raised to integration. In powers of e, we solve this integration. P is minus 2x. Okay, so let us solve that integration in power. Minus 2 is a constant. It will come outside x. What is the integration of x? The same formula. Okay, so you are familiar with this formula, I'm sure. X raised to n, that is x raised to n plus 1 upon n plus 1. Whatever the power, we increase it by 1 and the same denominator we write. Okay, so let me solve here. E raised to minus 2, derivative of x, power of x is 1, we increase it by 1, so x square divided by 2, 2 will get cancelled, e raised to minus x square. So this is the integrating factor. Okay, so we got integrating factor. Now just last step is remaining, that is solution. Okay, so let me write, just make a screenshot of it, then we will go for the solution. So now the solution is, let me write, solution is u e raised to integration p dx. I wrote u here since we have a differential equation in terms of u is equal to integration e raised to integration p dx q dx plus c. So let us put the values. Our u, what was our u? I think it was 1 upon y square. 1 upon y square. E raised to integration p dx, its value we have calculated, which is e raised to minus x square. It is e raised to minus x square. What is my q? Minus 2x cube dx plus c. That's it. This is our solution. But still one integration is there. That means we have to solve that integration. But that integration looks difficult since there is a product. And in powers of e also, we have some complicated function minus x square. Generally, when we have a u into v formula, getting u into v term, then we go for a u into v formula, that is integration by parts. But see, the first term looks complicated. So that's why I will not go for that integration by parts. Now the question is how to solve. The best method is substitution. I'm going to put that minus x square. Generally, whatever the complicated term you have in power or in an angle, we put that thing. So I'm going to do the same. I'm going to put minus x square is equal to t. But see, if you put anything there, its derivative must be near to it. Okay, derivative must be near to it. So minus x square derivative will be minus 2x. It doesn't appear here. Okay, but we can adjust. No, so let me show you how to adjust. E raised to minus x square. I will write minus 2x, minus x square. Okay, minus x square into 2x dx. Okay, just check. So 2 into minus 2, x into x square, x cube. That's perfect. Okay, and minus x square I'm going to put as t. So let us write, putting minus x square is equal to t. So in case of integration or in case of differential equation, when you put anything, the first task is to take its derivative. So let us take derivative. Derivative of x square is 2x, so minus 2x, and we write dx here. Derivative of t is 1, so we write dt here. So minus 2x dx will be replaced by dt. That 2x dx we have, simply we don't have minus sign. So I will multiply both sides by minus. So 2x dx will be minus dt. That is perfect. So 2x dx will be replaced by minus dt now. Okay, so I want some more space to write. Just make a screenshot of it. Then we will move further. So let us continue the solution. Okay, so I will copy the left hand side. 1 upon y square e raised to minus x square. Okay, integration e raised to minus x square means t, minus x square means t again, and 2x dx will be replaced by minus dt plus c. That minus sign we can take outside, and we have t e raised to t dt. So now there is a product again. Okay, so now the question is how to solve. So I'm going to use u into v formula. If you don't know, I will mention here. Integration uv will be u v1 minus u dash v2 plus u double dash v3 minus u triple dash v4 and so on. That means there will be two functions, function of product of two functions, right? We call the first function as u and the second as v. Generally, we take the polynomial function as the first function. So that's why I wrote t first, exponential function second. We take the successive derivatives of the first function, and for second function, we take the integrations, right? v1 means first integration, v2 means second integration, v3 means third integration, triple integration, getting? And alternating minus plus signs we have. So it means this is your u and this is your v. So let us apply this formula to find a solution. So minus t as it is, u as it is, v1, that means integration of e raised to t, minus sign is there, u dash, derivative of t is 1, v2, it's one more integration, e raised to t, plus u double dash, one more derivative of u, getting? So t derivative is 1, derivative is 0. So when you get 0, we stop the process. When you get 0, right? So here also I did the same. Shall I take that e raised to t common? So minus e raised to t minus 1 plus c. Yeah. So c, yes. So this is equal to minus, let me copy the left hand side, e raised to minus x square by y. T, what is the original value of t? Minus x square. So let us resubstitute. It is e raised to minus x square minus 1 plus c. So you can take minus sign common. If you take minus sign common, one minus is already waiting for it. So minus minus plus. So it will be e raised to minus x square x plus 1 plus c. So this is required answer, e raised to minus x square by y. This is the final answer. Okay, if you are really understood this problem, now then I'm going to give you one practice problem. You have to try that problem on your own, and in next video I'm going to solve. Okay, if you have any difficulty, you can watch my next video. Just make a screenshot of it, then I will give you the practice problem. So this is practice problem for you. Okay, if you have any difficulty, you can write to me in a comment. Okay, otherwise you will get its solution in my next video. Thank you.